Have you ever had a GM product give you a hard time starting? Only to deal with the pesky P069E for the fuel pump control module requesting the check engine light on. Here at DTech, this is how I went about diagnosing this problem on one of my buddy's trucks that he brought over for me to diagnose. Alright, so that's the symptom. Just crank no start, a couple tries to finally get it running. If you look for the trouble codes in the actual engine control module, and if you're using not an enhanced scan tool, if you're using like a code reader, you're going to get this P069E, which is basically the fuel pump control modules requesting the check engine light to turn on. And that's all that you'll be able to pull. And so we're going to try and figure out why that's coming on. Alright, so here's the wiring diagram for the actual fuel pump control module. I've got it pinned out to powers, grounds, the power for the fuel pump, also amperage here at the pump, and then the command from the engine control module. So we're going to take a look at all of those and try to see if we're losing any of these. And so that's what I've got running here on the scope. First we will do a prime and see if the pressure goes up. The red is the actual fuel pressure at the rail. Key it up. And crank. Alright, so finally got it running. We will turn this off and take a look at that. And just to show you, this is where the fuel pump control module is located. That's all our connections. And one thing to note, this vehicle already had the spare wheel basically removed. Cable did have an issue like most of them will have. So it won't be this easy to access. You'll have to get the wheel out of the way. The other thing sometimes keep in mind is it's hard to unbolt that module, and so we're going to try to avoid work that we don't need to do if we're going to have to deal with rusted bolts. Alright guys, so what we have here is a diagram of the fuel pump control module and the fuel pump. So here is the pump itself right here, and then this is the module. This is what basically the system is comprised of. These two main components, along with some fuses, are going to be our main system that is going to provide our fueling, along with the engine computer. This is going to be, let's call it, the one that controls the command to the fuel pump control module. It'll receive the command from the engine computer, and then this will control the fuel pump. So you've got a couple different things that come into play. Now, what we want to do is do some testing, because we've got a module that's involved that controls the pump. And between these two, none of them are going to be a quick, easy, or potentially cheap item to replace, and you don't want to spend the time, the hassle, the headache, and the money to make the wrong call and replace the wrong thing. Not to mention, the fuel pump module also would need to be programmed, and so it's an added, let's call it, inconvenience if you are a DIY or a shop that doesn't have access or readily available access to GM programming. Again, the other thing also to think about, you're dealing with vehicles that are of age, let's call it, and they've gained some rust. And it can become difficult when trying to access the module or removing the gas tank to get to the fuel pump, so on and so forth. So what we are going to do is test to avoid headaches where we don't need to be involved by going into the wrong area if we don't need to. And so in order for the system to work properly, the fuel pump control module needs to be powered up properly, grounded properly, and be commanded properly from the engine computer. Now the other thing, again, that I mentioned, the pump could potentially look like it's bad and faulty, and or the module can look like it's not operating properly if our ground or our power supplies are not good during the loaded operating state or attempt of operating state due to, again, rust built up on the frame or on the eyelid of the ground, so on and so forth. So again, you want to test if all it's going to be is a simple ground issue and not have to deal with the headaches of diving into a module or pump replacement. So enough preaching at this point. What I am going to look at, or what I want to look at, is a lot of things all at one time that's going to help me make a decision. So I'm going to tap into both these points right here. These are both power supplies to the module. Also the ground, because you don't want to see an elevated voltage on the ground side, which would indicate high resistance, which would be a voltage drop. And I also want to look at the power supply to the pump, which would come from the module. And I'm also, lastly, going to take a look at the command from the engine computer, because we can't have none of this working if this guy does not command this guy. And so I'm hoping by tapping into all of these, with the added portion of an amperage reading for the pump and a pressure reading from the fuel rail, all those combined should get us an answer. Now I want to look at amperage because I want to see if the pump is spinning and at how many amps. That can give me a good idea about the condition of the power supply, meaning if there is a supply issue when the system is loaded, the amperage won't be high at the pump. That's a quick guide if I'm not going to do load testing right away for my power feed and ground. Also, the power out to the pump, I want to check in order to see if the pump module is at least attempting to run the fuel pump. And so now if we move on to our scope capture that you saw us take, we've got a couple of things going on as far as events. So this section here, this section here, this section here were points of attempt to get the vehicle started and running. We were only able to get a cranking event. It never fully fired up until this point where you see it be continuous. The red is our pressure reading. We'll get to that basically last. Let's take a look at all the other ones. So first we'll look at channels A and C, which are going to be blue and green. We want those to be good constant power supplies to the module. And we can also look at channel E, which is going to be our purple. So this guy here, this guy here, and then this guy here. So we can clearly see that they're all towards the top. Let's get a reading. So purple, let's go green, and then blue. All of those are up high, 11 and change and higher. That is during our loaded state. So we're definitely not having a supply power issue to the module. If we look at our gray, which is going to be our command from the engine computer, and we'll actually take a look at it at this point and compare it to these points, our cranking events, because towards the right we know that we got it cranking and running. And so we'll watch there, and then let's check out our cranking events. So our first reading, this one, is going to be after we got it running, and it is almost 13. And the cranking event, we were in the 11 volts. So again, we are seeing the engine control module supplying a high signal, high voltage to the module to command it to provide, let's call it, a lot of fuel pressure. Okay, so we've got our power feeds that seem to be constant and stable. Our command is also good and present. Now let's take a look at our yellow or gold, which is our ground. Again, we do not want to see high elevated ground, which would indicate high resistance, which means that all of our voltage supply cannot return through the ground, and so the voltage level on the ground would be high. And normally you want to see, I think the industry standard spec is somewhere around 200 millivolts. That would be 0.200 voltage. So, and yes, it's a dirty signal. Let's see if we can clean it up some. And let's take a reading there. And that, to me, is right at somewhere where you want to have it. Again, it's around the 200 millivolts. And the more important thing is that it does not continue to rise to where we get half a volt or 1 volt or so on and so forth. So we're holding steady. We're not having a voltage drop because, again, our voltage level is not rising on our ground side. Now that's during cranking, and then it stays the same even through the other cranking events and when running. So we do not have a ground issue. So far this checks out, this checks out, this checks out, this checks out. This one checked out also, power supply. Now let's look at amperage and physical pressure reading. So this is our first cranking event. We know we spun the pump because we have activity here on our amperage reading. Now this is going to be basically where you're watching the fuel pump spinning and it's rotating as it's trying to basically push fuel out of the tank and up to the rail. And so the fact that we have our activity, our waveform being continuous, that tells us that our pump is spinning by this waveform, as you can tell right there. Amperage level, while it's spinning, will go towards the middle to get about an average. And so we are at about 1.1 amps. Now, I right now cannot tell you if that is good or bad. The one thing that I will look at is what does our amperage jump up to. That'll give us an idea about the loaded line, let's call it loaded power supply and ground. If we have high resistance, we won't be able to pull a lot of amperage. And so we're close to just under 11 amps. That's a pretty good amount of amps. Not the highest probably, but we are getting a high amount of amps. But now let's take a look at our amperage reading. And please forgive the noise. Hopefully I'm coming through. It is a crazy downpour right now. So hopefully you can hear me well. Our red is our PSI reading. our pump turned on and was spinning here in the blue, our pressure was a slow, continuous rise. Normally, you want to see our pressure be a higher, a quicker buildup of pressure, not the whole cranking event. Have it take time to build up pressure to a, let's call it max level at this point in time. Let's take a look at what that level is. We'll put that there, and let's take a look at time frame that our pump was spinning to see how long it took to raise up to that pressure. So it took 2 seconds to raise up to 7.5 psi. I think we're beginning to see a problem here. Our pressure did not spike up, shoot up as soon as our pump turned on and was supplied amperage and power and was spinning. It took us that whole 2 seconds to build up barely 7.5 psi. Again, I think we're on to something. Let's take a look at the other cranking events, because actually, now if I think about it, that could have been the prime. So it's a 2-second prime. So now let's take a look at our actual cranking event, and I can tell for sure because our ground signal is, let's call it a little bit dirtier. That means we were cranking. So this one was just prime. So prime was for 2 seconds, 7.5 psi. Let's take a look at our cranking time for this actual first cranking event and what our pressure built up to. We'll go here and then here, and let's get a PSI reading, which basically stays maxed out that whole time even when we were running. And let's see what it went up to. So just over 4.5 seconds to build up 23.5 psi. I think we're getting a good idea that our problem is going to be that our pump cannot provide enough fuel pressure. That is why it's taken so long to get the engine to finally fire up with, I guess, enough fuel pressure being brought up and maintained at the fuel rail to finally get the engine to spin over. Now we've checked everything else electrically, and we do not have high resistance. We have good power supply, and I don't have to load test it because we have about almost 11 amps at the pump, which means all of this is good. Our command is present, our power supply is there, our pump is spinning, but our pressure is not high enough. We have now just determined by checking these signals that the one component out of the two that is faulty is the fuel pump. Alright, and so after looking at all that and determining what we did, if you have an enhanced scan tool, you should be able to then scan the fuel pump control module. And there are a little bit more clues here in this module. So if we read the fault code, it does have a code that it stores. That's why it's sending a request to the engine control module. Basically, it's saying to come look at me and the code that I have. So this is the code that our situation is presenting to us. And again, you do have to verify everything that we just did before assuming that it might be just the pump. But the other things that you can look at, we can use the tool to try to look at some of the same similar data. So let's look desired fuel pressure and then actual readings, because this does have a pressure sensor that's connected to the fuel pump control module. Let's go to graph. And so It's keyed up right now. You can see this is our desired. Somewhere around 60 is what it wants. This is voltage, this is pressure. So we'll concentrate on this one. I'll go ahead and crank. We'll crank again. And there you go. So even at that point where we didn't fire up, and now even at idling while it is running, our pressure is nowhere near what it's requesting. So if you're able to get enhanced data in the fuel pump control module and don't have access to the scope, you can come in here and pull some of this information. Again, it's going to be a clue to tell you that we're going to have a pump issue. But again, you have to make sure you don't have a ground issue or a power supply issue back there, because if you cannot give it full power supply, the pump cannot consume the enough amperage to raise the pressure up. So don't make the mistake of not double checking, but this could be a good starting point to help guide you with what it could possibly be.